Hello, today our topic is quantization of orbital angular momentum. For the case of electron in an atom, electron is revolving around the nucleus having orbital angular momentum L vector. Now, according to quantum mechanics, electron is not allowed to any magnitude of orbital momentum value. That means it contains only a specific values of the orbital angular momentum and also not allowed to angular momentum directed in any direction in space, which means it can take only a specific orientation in the space. Thus, the electron faces large number of restrictions which is known as quantization. And also quantization means there can be a discrete values of the angular momentum. Now, for the case of electron in atom, results in certain quantum numbers put their restrictions to the magnitude and the direction of the angular momentum. So in first case, we deal with the magnitude of the quantization, that is magnitude quantization. Okay, now let us take an electron revolving around the nucleus and having a angular momentum L vectors. Now, the magnitude of angular momentum can be restricted by the quantum mechanics given by this equation. That is, magnitude of L vector is equal to root L plus 1 H cross, where H cross is equal to H by 2 pi and H is Planck's constant. And L is orbital magnetic quantum number. Where L can take its value 0, 1, 2 up to n minus 1. As we know that for L is equal to 0, there is s orbital, and for L is equal to 1, there is a p orbital. For L is equal to 2, there is a d orbital. So this equation basically results in the quantization of the angular momentum, because angular momentum now restricted to certain allowed values. It can take only a continuous values. Let us take the examples. For s is equal to 0, L is equal to 0, then magnitude of angular momentum is given by as a 0, 0 plus 1 is equal to 0. For P, sorry, here is okay. For P, L is equal to 1, angular momentum is given as a 1, 1 plus 1 H cross is equal to root 2 H cross. And for D, L is equal to 2, angular momentum is given as a root 2, 2 plus 1 H cross, that is root 6 H cross. So the angular momentum restriction in these values. Okay, so we can say that this is the quantization of magnitude of angular momentum. Now the second case is direction quantization. Now the first question arises, can the electron revolve around the nucleus in any orbital plane? Answer is no. The direction of electron revolve around the nucleus is restricted by the quantum numbers, and these restrictions are called direction quantization. Okay. Now let us take the case of the two orbits. First orbital has angular momentum in these directions, and the second orbital has angular momentum in this direction. where Lz is the angular momentum in the z-axis. Direction quantization basically results in the same magnitude of the angular momentum but different directions. If can take z-axis and look at the component of the two angular momentum, because now they have different direction of angular momentum, then the components will vary. So this will be the z component of the first orbit and this will be the z component of the second orbit. Okay, now by looking at the z component of angular momentum, of these different orbital planes, we have quantization rules. We have quantization rules, that is Lz is equal to ml h cross, where ml is equal to magnetic quantum number and ml can take the values from minus L plus 1 up to plus L. Now let us take the example of p orbital. For p orbital, L is equal to 1 and ml has values minus 1, 0, 1. Lz is equal to corresponding value minus h cross, 0, h cross. Now in these figures, this line shows the Lz has value h cross, this line shows the Lz is equal to 0, this line shows Lz is equal to minus h cross. In actually, to conserve the Lz is equal to h cross, the electron precesses about the z-axis. In other words, z-axis of the angular momentum is equal to the magnetic field on the electron. So as we know that in Larmor precisions, electron orbit precesses as the magnetic field direction. So in the similar case, Lz precesses about the z-axis. When Lz is equal to 0, orbit precesses in this manner, and when Lz is equal to minus h cross, orbit precesses in this manner. So we can say that for the p orbital, Lz is equal to particular values, that is h cross 0 minus h cross, which means angular momentum of a direction has a quantized value. So this whole phenomena is called the direction quantization. So we can say that quantization of angular momentum in magnitude as well as the direction of the angular momentum.